quantum numbers, the main contribution of the quantum mechanical model of the atom is that it gave us the set of numbers. Basically there were three. Fourth one was incorporated from the spectroscopy technique. So we get actually at the end the four set of numbers, which gives us the exact address or location of the electron in the atom, which we always wanted. Because after the Heisenberg's principle, we were knowing that electron can exist anywhere in the atom. So we were not knowing where exactly it is present. So we always wanted to have a certain law, or a certain equation or a formula or the numbers which can tell us where the electron will be. So that is what is the answer which was given by the Schrödinger in the form of what? Quantum numbers. So what are quantum numbers? Are set of four numbers which gives the exact location of the electron in the atom. Now, out of these four numbers, the three were derived from the quantum mechanics, as I have explained you, and the fourth one was incorporated from the spectroscopy techniques in order to accommodate two electrons in the orbitals, and there were some later on complications because of which the fourth one was introduced. So we have at the end the fourth set of quantum numbers. Now let us understand these four quantum numbers one by one. The first quantum number is called principal quantum number. It's called principal quantum number. Its symbol is N. It's also called Bohr's quantum number because it was given by Bohr. So what is principal quantum number is? It is the number of orbit, or we can say it is the orbit number to which the electron belongs. Then it gives us the radius of the orbit or distance of electron from nucleus. It is also used to determine the energy associated with electron. So first, the N tells us the orbit number to which the electron belongs. With the help of this, we can find out the radius, the energy, and the velocity of the electron. And then, most important, this N is always a natural number. That is, N can be 1, 2, 3, 4, 5 like this to up to infinity. So we can have N number of orbits around the nucleus, but we were knowing the electrons will be existing only in those orbits as per the Bohr model, in which his electron in its energy is quantized and is equal to by the formula -1312 z square over n square, and its angular momentum is integral multiple of h over 2 pi. So that one we were knowing already. So but there are n possible values which are present around the nucleus and orbit, and therefore its number is always the natural number existing from 1 to infinity. Now this also tells us, this orbit number gives us about idea about how many subshells we can have in any orbit. Always remember, the number of subshells in an orbit is equal to the orbit number. It means what? In the first orbit, there will be one subshell. In the second orbit, there will be two subshells. In the third orbit, there will be three subshells, and so on. The most important. So, your first quantum number, n, talks about mainly the orbits. Let us move to the second quantum number.